So let's try to sketch a graph of this thing, and let's make sure our graph has some correct properties. Let's make sure it has the right intercepts. Let's make sure it has the right asymptotes. And let's make sure that it is positive/negative in the correct places. So I guess if it needs to have those things correct, we should start by finding them. Let's find the x-intercepts and y-intercepts. So for this function, either how do you find the x-intercepts, or just what are the x-intercepts? So how do you find the x-intercepts of a rational function? Yeah. Plug in 0, 4. That's how you find the x-intercepts of absolutely anything. No, you're faulty. You're faulty. That's how you find the x-intercepts of anything. So set 0 to y, so we need to solve 0 equals x plus 1, x minus 2, over x plus 2, x minus 1. We need to solve that equation. That looks like an equation that's reasonably easy to solve. Yeah, so I guess the first thing I see is it's a fraction. So what's the only way a fraction can be 0? Yeah. Opposite.
Right.
If the thing on top is 0. If you don't like the words numerator and denominator, you don't need to use it. The thing on the top of the fraction is 0. So to solve that, it would be 0 equals x plus 1, x minus 2. Does that look like an easy equation to solve? What are the solutions? -1 and 2. Either this piece is 0, x equals -1, or this piece is 0, so x equals 2. So the x-intercepts will be -1, 0, and 2, 0. -1, 0, 2, 0. And I'm not going to be too worried about having the scale correct, but 2 should look good. All right, what about y-intercepts? How do you find them? Come on. I don't. I think you're both going to say the right thing.
X equals 0.
Awesome, you agree. Set x equal to 0. To get the y-intercept, set x equal to 0, plug in, you plug in x equals 0, what do you get for this output? Let's say I'm on the confidence. A 0, 1. Do I hear a second for 1 or a different answer on that 1? Cool. Can I get -1? Okay. Yeah, 1 is fine. I just wanted to see if I should belabor the point. All right, so 0, 1. I didn't do any walk there. Can I actually go through the walk plugging in there? Okay, I will do. Let's plug in x equals 0 and see what we get. We will get 0 plus 1 multiplied by 0 minus 2 all over 0 plus 2 multiplied by 0 minus 1. All right, so let's just evaluate that out. 0 plus 1 is multiplied by 0 minus 2 is 1 times -2. 0 plus 2. 0 minus 1. And now let's work out the numerator and the denominator and then simplify out. 1 times -2. -2 all over. Oops, that's way too far down. -2 over -2 is 1. So you'll notice that I wrote out every step. I think this is the type of computation where if you do it too quickly or too in your head, you'll wind up losing a negative sign. Cool. So was that helpful? Excellent. So 0, 1 is the y-intercept. Let's draw that. 0, 1. All right, particle asymptotes. How do you find the particle asymptotes? So the particle asymptotes will recall when you divide by 0. So, for this function, if you want to see when you divide by 0, what do you need to set equal to 0? The denominator. To find the particle asymptotes, set the denominator equal to 0, x plus 2, x minus 1 parentheses matter equals 0. And where did that come from? That came from the denominator. All right. That looks like an easy equation to solve. Is it like really convenient that in this problem absolutely everything in sight is pre-factored? Would this still be doable if it weren't factored? Yeah, you just have to like use the quadratic formula or factor the thing yourself. What are the x values that give a particle asymptote? -2 and 1. -2 from this term, 1 from that term. So, x equals -2, x equals 1. Let's draw those. X equals -2, x equals 1. All right. People feel good so far? What about the horizontal asymptote? Where is it, or how many do you find? Yeah. No, that's how you find the x-intercepts. Yeah. Yeah. So you do this thing involving the degrees of numerator and denominator. What's the degree of the numerator? What's the degree of the denominator? Nice. When that happens, you should take the ratio of the leading coefficients. So if you want to FOIL out the numerator, I'm not saying you, but if you want to FOIL out the numerator, what would the leading coefficient be? Same in the denominator? Oh, sorry, do the same in the denominator, and what is the leading coefficient? So I wasn't asking you a yes or no question. So, leading coefficient for both is 1. 1 over 1 is 1. So to find the horizontal asymptotes, here's one way to think about it. The degree in numerator is equal to the degree of the denominator is equal to 1. So the is equal to 2. So the horizontal asymptote will be at y equals the leading coefficient of numerator divided by the leading coefficient of denominator, which will be 1 over 1. That fraction is 1. So, horizontal asymptote is at y equals 1. All right. Let's also do that one other way, which sometimes will feel more intuitive. The horizontal asymptote is what happens when x is gigantic. So here's another way of thinking about this. So when x is big, y equals x plus 1, x minus 2 over x plus 2, x minus 1 is about, if you plug in a really big number for x, does that plus 1 make much of a difference? Nope. Does the minus 2 make a difference? Same with the plus 2 and the minus 1. This is about x squared over x squared, which is 1. There's another way to find the horizontal asymptotes. Cool. The final thing to check is this thing needs to be positive and negative at the right times. And the places where the positivity or negativity can change, our vertical asymptotes and x-intercepts. So that means all the way from negative infinity to negative 2 will either always be positive or always be negative. One way to figure out which is to plug in a sample point. What is a sample point less than negative 2? Negative 2. Cool. Oh, well. So let's test x equals negative 3 and see what we get. Negative 3 plus 1, negative 3 minus 2, negative 3 plus 2, negative 3 minus 1. And I won't try to compute this on the nose because I don't care about its value on the nose. Right now I just care whether it's positive or negative. Too many things in the box. Negative 3 minus 1, positive or negative? Negative. It's negative 2, but I don't care about that. Negative 3 minus 2. Negative. Negative 3 plus 2. Negative 3 minus 1. So I see a negative times a negative divided by a negative times a negative. What will that be? So that means that all the way from negative infinity to negative 2 will be positive. And it needs to go to this horizontal asymptote. So for x values that are super negative, it needs to be basically 1. And then I need to get to this vertical asymptote. That means the y values will either go up to plus infinity or down to minus infinity. It can't be negative, so it can't go to minus infinity. I've crossed the vertical asymptote. That was poorly done. People feel pretty good? All right. So let's talk about a way we could have bypassed that bit of computation. If I plug in an x value that is extremely negative, I should get a y value that's close to 1. A y value that is close to 1, will it be positive or negative? Positive, right? If I plug in something that's close to 1, I should get, if I plug in something that's like x equals negative 10 trillion, I should basically get an output value of 1. Output values of 1 are positive. So I didn't need to do that computation at all. I could have just used the horizontal asymptote. In fact, let's talk about how to bypass the next bit of computation. So the next range is between negative 2 and negative 1. What's a sample point you could use in that range? What's the number between negative 2 and negative 1? Awesome, negative 1.5. So you could now plug in negative 1.5, negative 1.5, whatever you want, and decide, well, no, let's actually do it. Let's plug in x equals negative 1.5 and play the same game. Negative 1.5 plus 1, negative 1.5 minus 2, negative 1.5 plus 2, negative 1.5 minus 1. And let's play the same positive or negative game. Negative 1.5 plus 1. Oh, sorry. Yeah. Negative 1.5 plus 1. Negative 1.5 minus 2. Negative 1.5 plus 2. Negative 1.5 minus 1. The end result will be negative. And notice what changed. This piece changed. All the others stayed the same in terms of positivity or negativity. Whenever you cross through an asymptote, a vertical asymptote, or an x-intercept, whether the sign changes will be completely determined by the thing that gave you that vertical asymptote. This term goes from negative to positive, so the sign of the whole thing will change. So it has to go to negative infinity, and then get to this vertical, get to that x-intercept. All right, what's an input between negative 1 and positive 1 we can check? In fact, have we already checked 0? Awesome. Was it positive or negative? Positive. So I have to go through to the positive side, get up to that vertical asymptote. problem without doing any computations. Let's just look at this and decide whether I should change sign or not. At that particle asymptote, should it change from positive to negative or stay the same? Do I hear it change from positive to negative? Do I hear it stays the same? Okay, with no votes, let's discuss. So there's a particle asymptote at x equals 1. What ingredient of this rational function caused that particle asymptote? The x minus 1 term did? So this is caused by 1 over x minus 1. At x equals 1, this changes sign. Right? It will go, yeah. Oh, yeah, absolutely. Yeah, so I'm trying to, weirdly balance, the fact that what I'm graphing is at the top of the page and the bar chart at the bottom, so I want to show both, but I can't. But I know? And it's not really readable because my handwriting was a little bit bad. So the particle asymptote at x equals 1 was caused by 1 over x minus 1. That term changes from negative to positive. So the whole thing will change sign at that point. So that means this function will change either from positive to negative or negative to positive at this input. It was already positive, so it has to change to negative. So it has to change to negative and get to the particle asymptote and then to the x-intercept. All right. And what about from x equals 2 to infinity? Let's do it by thinking about whether it should change sign. So which piece of the polynomial caused the x-intercept to 2? X minus 2. Will that piece change sign at x equals 2? Yeah, it'll go from negative to positive, so the whole thing will go from negative to positive. So we'll crash through and become positive, and then I need to get close to the y, to the horizontal asymptote. Cool. How do people feel about that graph? Does that graph cross through its horizontal asymptote? Sure. Yeah. Which is just fine. You're allowed to. This was I just wanted to point it out in order to. And in fact, the y-intercept was exactly at the horizontal asymptote, so it definitely had to touch that asymptote. Cool. People feel pretty good? So, I think the thing I want to do next is flip over to the next page. So some organicness is lost because I can't give you questions out notes, but I think it's worth it. Here's another example. I'm not going to do this as a quiz. I'm not going to collect it. I'd like you to make an attempt, follow the same line of attack, make progress on this statistical problem. And as you go through the process, absolutely ask any questions at any point. I'm going to take this time to pretend. Which means I should follow. Oh, yeah, absolutely. You should. You should absolutely walk with anyone else in the classroom you want to. If people want to organize it, then you can walk with the whole damn room. You can also move seats if you want to. It looks like that's maybe an issue. The seats also have wheels. All right. Yeah. Where is the 2x minus 3?
Oh no, that's a what? That's a what? Right? What happened? No.
So go to the next slide. I think another number changed. Let's see. 2x minus 2, I see 2 times 0 minus 1. The next one. And then 0 plus 2. 0 plus 2, 0 minus 2. So with that change, how do you do it? All right. Then what is that? Awesome. Negative divided by x will be positive.
I think so. I think the y is what I did was I was here. And then I did that.
Why did you forget about set design?
Oh, wait.
Is it still to divide this?
Did you divide this by
Yeah.
Oh, yeah.
So I guess just put in extra steps there, which put a slash and then the denominator will that. No, you're good. Yeah. I don't know whose hand is up last.
Oh, I don't know.
Okay, you're researching.
Yeah. I was wondering why.
So this piece is negative. So the whole numerator will be positive. And then it will be divided by a negative.
Oh, I see. So then when I look at 0,
Which is actually already means it has to be because you already said
oh,
This one.
Vertical at 2, negative 2, 2, and a horizontal 1, 2. Okay.
after this is the
Ready? Yeah, what is
So, why did you check?
Let's try that.
What people will try to study by plugging
I think what he did was tell something I'm getting ready to. So let's do it.
But I see it like something that
and put it in the equation?
Yeah.
So you want something to the left of negative 3.
Oh.
Yeah.
Oh,
You do it right. Don't you?
yeah,
You did do it
yeah.
right.
I just wrote it.
Yeah, you said not confident, but that makes sense. Yeah, so one of the you can also think about like, forget about everything that's not the biggest problem added together. So you can forget about all the pluses or minuses.
This is 0.
Remember the times two. Awesome.
It's positive. No, it was like, I mean, it had a
This one we got close.
2 and negative 4. Yeah.
What do you mean by one?
Zero.
Because all more classes are more
Yeah.
Yeah, we're more classes. So they should be two more. And if you
No,
want
a negative times a negative is positive. And then negative times a positive is negative is positive. Because a negative divided by a
How many
negative.
exits? How many, so now look at how many exits are there?
I think so.
So
So, because negative times a negative is positive. Yeah.
there's something wrong
Something negative. And then the negative divided by a positive is a negative.
with yeah. Excellent.
Yeah.
by literally just plugging things in. So, what is a, so what were the x-intercepts? We find the x-intercept so in particular, there can't be a dot and a vertical line at the same time.
I have a question about the so like is that was it
There is a thing in Canvas.
okay, straight up the entire story.
Yeah.
So like putting images
This document will not be flat. Yep, that's the one which, during the review day for the big talk, I will answer absolutely any question about this.
Okay.
If you ask me a question about the thing on Canvas, I'll be like pretty basic and dodgy about it.
Okay.
Yeah.
Yeah.
Oh, yeah, absolutely.
So we messed up our business.
Oh, it's good. Good. Tell me about this 1.5. Is that 1.5?
No, that's.
Okay. Cool.
This is the part of it.
Nice. Where is the water class in total? Where are the water classes?
So it's negative 2 that's human and the horizontal is also.
Cool. Yeah. Unlike some of us, it's nice to label those.
Yeah.
But like. So, I think let's come together. Let's spend some time on this, and then we'll talk about inequalities. So, let's answer some questions about this. Where are the x-intercepts of this graph? Cool. So there's one at x equals 1. Yes. Yes, it is supposed to be. Thank you for pointing that out. There should be one at x equals 1, one at x equals negative 3. Where's the y-intercept? 3 halves, which I'll label as 1.5 because that's easier to see how big it should be. Any questions about y-intercept? It sounded like there were some exclamations or question marks at the end of one of those 3.5s. Anyone get different things? Cool. Let's talk through it. So how do you find the y-intercept? I suspect you lost A2. So let's plug in x equals 0 and see. So it'll be 2 multiplied by 0 minus 1 multiplied by 0 plus 3 all over 0 plus 2 times 0 minus 2. Let's just work out what this is. 2 multiplied by negative 1 multiplied by 3 all over 2 multiplied by negative 2. Do you see a 2 that you missed yet? Oh, well, that would work out fine. Then this would become like 2 times 0 minus 2 if you multiplied through first. Cool. People feel good? Awesome. Vertical asymptotes, where are they? Negative 2 and 2, and x equals negative 2 and 2, because they're vertical. X equals negative 2, x equals 2. Horizontal asymptote. Y equals 2, which people happy so far? Any questions about those details? Let's check for positivity / negativity. For x values less than -3, will it be positive or negative? Positive. Did you do that by plugging in? Nice. You could have done it more easily. If x is like -25 billion, the y value should be basically 2. Is something that's basically 2 positive or negative? Positive. So you could have avoided the computation, but it's not wrong to do it. All right, so it will be positive, and then it needs to get down to x equals -30. So I showed no details there. Do people want to see any details of that step? Cool. So let's do it this way. So when x is like -infinity, the y value should be about 2. Because you know what the horizontal asymptote is. Is a number that's close to 2 going to be positive or negative? Positive. It'll be like 1.999999999, which is positive. So it has to be positive when x is really, really big and really, really negative. And there's no x-intercepts until x equals -3. That's the first chance it has to change to negative. Alternately, you could plug in an input. What input did you use? That's a reasonable input. You could also plug in -4, see if it's positive or negative. I'm going to avoid doing the actual calculation. What about between -3 and -2? Positive or negative? Negative. Well, maybe I'll see a general poll. Positive? Negative? Unclear. I feel like everyone's hand should have gone up for one of those, and I don't think everyone's did. How did you decide negative? Cool. What did you plug in? -2.5. Let's try that. When x equals -2.5, I'll see 2 times -2.5 minus 1, -2.5 plus 3, over -2.5 plus 2, -2.5 minus 2. And let's just label each of the pieces. 2 is positive or negative? -2.5 minus 1. -2.5 plus 3. So the whole numerator will be negative. -2.5 minus plus 2. This piece. So the whole denominator will be negative divided by positive is negative. Cool. So the graph should now carve down to -infinity. Does that feel pretty okay? The next interval to worry about is -1 to 1. What's the sample point in that interval? 0. In fact, have you already evaluated it at x equals 0? Yeah, you got the y-intercept, so you had to. So, has to go to the vertical asymptote, get to the y-intercept, get to the x-intercept. People feel good right now? Between 1 and 2, should it be positive or negative? Negative. And one way to do it would be by plugging in a sample point. The other way would be, well, at x equals 1, here's the piece that causes that x-intercept. That piece is going to change from negative to positive, so the whole thing has to change sign. Cool. Oops. People feel pretty good about this? Groovy. So with my remaining time, there's only a very small idea I want to introduce, and that's how to solve inequalities that involve rational functions. And well, maybe before I do proceed, do people have any questions about this that they want to ask before I do move? Okay, cool. Let's solve an inequality. And so maybe I'll give you first an overview of what this note packet has. On page 1 of this note packet is solving this inequality incorrectly. And in fact, let's do that. So we have an algorithm that solves inequalities. I want to show how to revise it for rational functions. So let's first observe that it needs to be revised. What's the algorithm we have right now to solve an inequality? What's step 1? Solve equality. That'll tell me like the end points. Then I'll pick some sample points to decide where the inequality is solved. And I think I want to change all of these to bigger than or equal to. Just because I'll see something else happen if I do. All right, so if I want to solve that inequality, first I should solve equality. There's an equality to solve. Does that look like well, if you saw that equation, how would you want to solve it? What's step 1 to solve that? Multiply both sides by x minus 1. There's a fraction. The fraction is annoying. How do you get rid of a fraction? You multiply by the denominator. So let's multiply both sides by x minus 1. That becomes x plus 1 over x minus 1 times x minus 1 equals 2 times x minus 1. Whole reason to do that is so these cancel. And maybe I'll distribute the 2 as well. Does that new equation look easier than the original one? Great, that's progress. If you do move and it doesn't look simpler, then maybe it was a bad move. All right, but that looks easier to solve. What would you want to do to get x on its own there? What seems like a good thing to do? Yeah.
Probably move the x from the left side over to the right side.
Move the x from the left to the right by subtracting it. All right, and maybe we'll do more things. What else would you want to do in this same step? Move the 2 over by adding 2 to both sides. What do you get when you do that? X equals 3. So it looks like x equals 3 is the solution to equality. Okay, so we find the solutions to equality. What's the next step in the algorithm if you want to solve inequality? Yeah. Check some sample points. What is a sample point you would like to plug into this? 0. Let's plug in 0. That'll give me something to the left of 3. So let's plug in x equals 0, see what we get. We'll get 0 plus 1 over 0 minus 1. I would like to know, is that bigger than or equal to, question mark, 2? Is it bigger than or equal to 2? No. So what conclusion should I make? 0 isn't included, so none of these can be included. And I'm going to remark that there's a mistake in what I just did. And we'll see the mistake soon. What's a sample point bigger than 3? 4. When you plug in 4, what do you get? Is that bigger than 2? Cool. Let's talk about how to compare fractions. The easiest way, if you don't want to deal with like decimals, is to clear denominators. Is 5 bigger than or equal to 2 multiplied by 3? No. So what conclusion should I make? Well, x equals 3 is the solution. This seems to make it look like x equals 3 is the only solution. That seems unlikely. In fact, if I still have it pulled up, which I better, here's the graph of x plus 1 over x minus 1. That blue line is at y equals 2. Is this graph ever above 2? Looking at this graph, what does it look like the solution should be? Looks like it should be from that vertical asymptote on to the point where they cross. Where's the vertical asymptote of this? 1. So by looking at a graph, it sure seems like 1 to 3 should be the solution. 1 has to be excluded because it's not even in the domain. 3 should be included because I wanted to solve equality. So our algorithm failed. It failed because of the particle asymptote. So here's what we'll do with my remaining 3 minutes. Let's revise the algorithm, and then we'll run it really quickly in this example, producing this solution. So here's the revised strategy. Step 1, find solutions to equality. Those are still relevant. Particle asymptotes can also screw us up. So step 1b is find the particle asymptotes. What do you set equal to 0 to find particle asymptotes? Denominator, the thing at the bottom of the fraction. So set the denominator equal to 0. Those will give you your endpoints. Your endpoints will be denominators and solutions to equality. Next step, check between and beyond to see which intervals solve the inequality. Be careful with your endpoints. And in particular, I'll make this comment. Will the location of a particle asymptote ever solve an inequality? No. Why not? Can't divide by 0. Particle asymptotes correspond to dividing by 0. You can't divide by 0. Particle asymptotes won't even be in the domain. So, no matter what inequality you're solving, particle asymptotes will never be included. So, I have like 2 minutes. Let's solve this inequality. We've done most of the steps already. So step 1, solve the equality. What was the solution to equality? 3. Where are the particle asymptotes? That means 1 and 3 are important. I already checked a number that was bigger than 3. You told me to check 4. I plugged in 4. Did I get included or excluded? Exclude. So everything bigger than 3 should be excluded. I plugged in 0, and I got exclude. So all of these inputs should be excluded from the solution. It looks like I need to check a sample point between 3 and 1. What's a number between 3 and 1? 2. That'll give me 2 plus 1 over 2 minus 1. I think that's 3. Is 3 bigger than 2? So, what can I say about things between 1 and 3? Will they satisfy the inequality? Yep. So I should include these. It looks like the solution to this is an interval from 1 to 3. Let's decide about endpoints. Should 1 be included or excluded? Excluded. It's a particle asymptote. Particle asymptotes will always be excluded. Should x equals 3 be included or excluded? Included. It corresponded to equality, and I wanted to solve bigger than or equal to. Because of that, it needs to be included. So that was very fast. Here's what I'd like you to do this weekend in order to decide if we should spend more time on this. There's another inequality at the bottom of this page. Solve that inequality. Check your answer by looking at the graph. Has anyone been taking advantage of the QR codes in the notes? Okay, it's a useless bit of shtick. I was proud of it, but if it's useless, it's useless. When you're going through these notes on your own, you absolutely can't use your phone and use those QR codes.
Maybe you just pull up for us.
Yeah, in class. And I definitely can't do that in class because this thing doesn't have a QR code scanner. I guess I don't think I can use QR codes on this, can I?
I was in math and they said
That's true.
have you been to Hot California?
Never been to Hot California.
Because my mom still doesn't know how it is. Because she's obsessed.
What city is it? Canada's a big
I
country.
can't remember. Okay.
Okay.
I know it's not that far off from like Minnesota. I know it's not that far from.
Oh, okay. Is it in Winnipeg?
I'm gonna look it up.
Okay. I mean, that doesn't change the answer. I haven't been.
Yeah.